Now that we've discussed the basic idea about what an exponential model is and why it might be useful, let's delve into the mathematics. So the general form of an exponential function will be something of the form a is some real number times b to the x power. And b here is a number, a real number, so let's go ahead and include that. So some real number, which is bigger than 0. So for example, 5 times pi to the x power would be a exponential function. So for example, 5 times pi to the x would be an exponential function. 5 is a real number, that would be the a, and pi is a real number, which is bigger than 0, that would be the b. Negative 3 times 12 to the x would be an exponential function. 2 times 1/3 to the x would also be an exponential function because 2 is a real number and 1/3 is a real number greater than 0. So all of these are exponentials. And by exponentials, I mean exponential functions. Some functions don't initially look like exponential functions, but are exponential functions. So for example, 4 to the 7x plus 3, that doesn't look like the form that we have here for f of x, but you can use some properties of exponents to make it look like this form that we have, a times b to the x. So we can distribute the 7. So this is 4 to the 7x plus 21. Now you will need to remember your properties of exponents here. If you have an exponent, or excuse me, a number raised to a sum, that is equal to that number to the first part of the sum times that number to the second part. And when you have 4 to a product, or any number to a product, remember that if you have a to the b to the c power, that's a to the b times c. And so 4 to the 7x, that would be the same as, I'm going to write this 4 to the 21 first. That would be the same as saying 4 to the 7, all raised to the x power. If you're out of practice with working with these exponential rules, it will be useful for you to find any textbook on either college algebra or some pre-calculus textbooks and refer to the properties of exponents sections. All that being said, what we have here is a real number. 4 to the 21st power is a real number. It's a really big real number, but a real number nonetheless. Also, 4 to the 7th is a real number, also a large number, and it's being raised to the x. So a here is 4 to the 21, b is 4 to the 7. So we have ourselves an exponential function because this function can be rewritten as a number times a number to the x power. Another example that comes up of an exponential function is when you have to a minus x power, because if you remember, if you do to something to a negative power, that is the same as 1 divided by 2 to a positive power. And so what we have here is 2 to the minus x is 1 over 2 to the x, and this is the same as 1/2 to the x. Again, these steps are simply using properties of exponentials. So I have here a number to the x power, which gives me an exponential function. Now you might say, where is the number that comes before? Where is the a? Well, a in this case would be 1. So all of these that I am putting a check mark beside are exponential functions. Now, one that might look like an exponential function but is not is something that looks like the following. Let's say we did 2 to the 1 divided by x. There's no way to rewrite this in the form a times b to the x. This 1 over x represents a root. For example, 2 to the 1/2 is the square root of 2. So there we have the mathematical definition of what an exponential function is and some examples of what exponential functions might look like in practice. Now let's conclude with an important definition. In exponential functions, the number b has a definition, or perhaps a name. So b is called the base of the exponential function. So if I have my exponential function of -3 times 12 to the x, we would say that the base is 12.